Hello, in this video, we will begin to introduce objects and classes in Chapter 9. You have learned the materials in the preceding chapters. You are now able to solve many programming problems by using selections, loops, functions, and lists. However, these features are not sufficient for developing graphic user interface or a large-scale software system. Suppose you want to develop the GUI as shown in this figure with the buttons, the labels, text field, checkboxes, and radio buttons. How would you program it? This chapter introduces object-oriented programming, which will build a foundation that enables you to develop GUIs and large-scale software systems in the upcoming chapters. Let's look at the objects and classes now. What is an object? We already used objects. An integer is an object. A string is an object. Object represents an integer in the real world that can be distinctly identified. There are many other examples: a desk, a computer, a student, a circle, a button, even a loan can all be viewed as objects. An object has a unique identity, state, and behavior. An object's identity is like a person's social security number. Python automatically assigns each object a unique ID for identify the object at runtime. So you can use the ID function to obtain the ID for the object. An object's state, also known as its properties or attributes, is represented by variables called data fields. For example, a circle object has a data field radius, which is a property that characterizes a circle. A rectangle object has the data fields width and height, which are properties that characterize a rectangle. Python uses methods to define an object's behavior, also known as actions. Recall that methods are defined as functions. You make an object perform an action by invoking a method on that object. For example, for a circle object, you can invoke its method getArea to return the area, getPerimeter to return the perimeter. Objects of the same kind are defined by using a common class. The relationship between classes and objects is analogous to that between an apple pie recipe and apple pies. You can make as many apple pies as you want from a single recipe. A Python class uses variables to store data fields and defines methods to perform actions. A class is a contract, also sometimes called a template or blueprint that defines what an object's data fields and methods will be. When you create an object from the class, that's called instantiation. The term of object and instance are often used interchangeably. An object is an instance, and an instance is an object. So look at this figure. We have the class SOCO. SOCO has data field to describe the property for object. It's a radius, and these are the methods: get area, get perimeter, set radius. So these are the instances of the class SOCO. So SOCO object 1, object 2, object 3, and with the data fields, radius is 1, 25, and 125. Now, let's see how we're going to define the class. Define the class using the syntax: class, followed by class name and the colon symbol. Inside the class, we'll have the initializer and methods. So this is a class SOCO. We're going to define the initializer. So this is a special method. It is to initialize the object. So here we're going to have this is you have to write self. You have to write a self. So this is to refer to the object itself. So now we're going to have this self dot radius. Assign this radius to the object's radius. So this is the radius you're going to pass from the user when the user creates a SOCO object, specifying the radius. Get radius, get parameters. So this is get parameter is self dot radius times pi. And you should have this 2 times. So this is diameter times pi, that's the perimeter. And the area is the radius times pi. So look, this, we have the self. So this is object's radius times the object's radius times pi. Set radius, we set this object's radius, self dot radius, using this new radius. You have the class now. How do you construct an object? Once a class is defined, you can create objects from the class with a constructor. The constructor does the following thing. It creates an object in the memory. It invokes the class init method to initialize the object. So this is, here is the steps. First, the constructor creates an object in the memory. So this object is now here. And now invokes the init method to initialize the data in the object. So this is the example for the SOCO object. This is the SOCO here. We're going to create the SOCO object and now invokes the init method to initialize the SOCO using the data field, using this radius is a 5 for the data field. So this is here, and the how you construct it using the syntax is just have the class name and it provides the arguments. So the arguments here, those are the arguments you're going to pass to the init method. So please note that this init method for the SOCO has this two arguments, self and radius. Now self is the object itself. So the radius is the one you're going to pass it from the constructor. So when you construct it, so you can use things like SOCO 5. So this is SOCO 5. So 5 is the radius. So when this SOCO 5 is invoked, it creates a SOCO object with radius 5. You can also use this SOCO without any argument, and then the default radius 1 is used. Once you create the object, how do you access the members of the object? So this is the object reference. So here's the reference variable that refers to the object. So this is, you have this created. So for example, here's SOCO 5 is now SOCO 1 references SOCO object with radius 5. And this SOCO 2 references the SOCO object with radius is 1. So now you can use this syntax is using this dot operator to access the data fields and to invoke the method. So for example, we create the SOCO 5. Now C is reference variable that references the SOCO object with radius 5. Invoke C.radius, so that's 5. Invoke C.getPerimeter, so that is the result for the perimeter. Invoke C.getArea, that is the result for the area. Now, you can also use anonymous object. Here we're going to print area is, so this is SOCO 5, this object. It is not assigned to a reference variable. You can use it directly here, get area. So now let's look at this magic self parameter. So what is the self parameter? Self refers to the object itself. When a method is called on an object, self is set to the object. Using self, you can access objects members. So here, this is the class here. It's a self right here. And look at the self here is the, so you now create this data field x self.x. Now self.x can be now used for all the objects. Now this is the for all the methods. The scope of the self x is now the entire class. So this is the scope for z now. But this, what, see the difference? This is self y and this is just z. So z is only used, the scope is z is from here all the way down to the end of this method m1. So this self.y, so this is for the entire class. You can use here self.x. So now self.x is 1. So this is self.x is used here. So this is the self. Let's put everything together in an example now. Let's call this a test SOCO.py. So we define the class SOCO. This is the init method. So here we have the this get perimeter, get area, set radius. So we create SOCO 1 and create a SOCO 2, so create a SOCO 3 and use all this. Let's look at this animation, see how this works now.
Math module. The program imports the math module. The program loads the definition of the circle class to the memory. The program loads the definition of the main function to the memory. The program invokes the main function. The main function is invoked. The statement will create an object and assign its reference to circle 1. The constructor is invoked to create an object. An object is created and the init method is invoked to initialize the object. The default radius value 1 is assigned to object's property self.radius. Variable circle 1 now references the object. Check your understanding. What will be circle1.radius and circle1.getArea? Enter these values separated by a space.
Circle1.radius is 1. And circle1.getArea is 3.14.
You are correct. The statement will create an object and assign its reference to circle 2. The constructor is invoked to create an object. An object is created and the init method is invoked to initialize the object. The value 25 is assigned to object's property self.radius. Variable circle 2 now references the object.
Now through this animation, you see how an object is created and how object is initialized and how you access the object's data and invoke its method. So this is a test program in live example. You create a circle using the, this is a no-arc constructor using the, and here using the default radius. And now this is circle with this 25. And here, this is get the area of the circle here for circle 3 dot get area. Now let's look at the objects versus variable. So you create an object assigned to the reference variable. So here, the distinction here is this, a variable that appears to hold an object actually contains a reference to that object. Strictly speaking, a variable and an object are different. But most of the time, the distinction can be ignored. So it is fine for simplicity to say that circle 1 is a circle object rather than using long-winded description that circle 1 is a variable that contains a reference to a circle object. Look at this diagram. Suppose C1 and C2 are two circle objects. Can you copy the contents of C2 to C1 using this assignment? No, this is not the copy contents. This is just the copy the reference of the object to C1. So here, look at C1 is reference to this object. C2 is to this object. Now, when you do assign, so what happens is C2, you are going to have the reference now assigned to C1. So C1 and C2 all point to this, the object C2. So this object is not referenced by any variable, and this becomes a garbage. The Python interpreter automatically collects it and destroys it. All right, in the next video, we will look at the UML class diagram. Thank you for watching. See you on the next video.